Hi team! We all know that really great robots don't just perform the basic game actions, they perform them reliably and accurately. Reliability and accuracy depends both on mechanical design, but to a large extent it also depends on how software controls your things. And there's not a lot of understanding in the mechanical subteam right now about what's required in order for software to be able to provide reliable control. Spoiler alert, here's the short answer, it's in this box. Software can only guarantee reliable control if there's a sensor to measure what it is that you want controlled. Let me give you a case study this year for our shooter. So early in the year, here's the kind of thing I heard mechanical students saying. They were saying, okay, so we've got this indexer, and it's going to feed balls into this rotating flywheel that's the shooter, and then the flywheel will shoot them out. So here's what's going to happen. We're going to drive up to the boiler, and we'll hold down the trigger of the joystick, and we'll shoot one ball. And if the ball looks like it's a little bit short, we'll increase the speed of the flywheel and shoot another one until eventually we get one in. Now we know that we've got the flywheel shooter speed correct, and so we'll just hold down the trigger and continuously feed in balls from the indexer into the flywheel. It's rotating the right speed, and so we should be getting balls in like gangbusters. We should be able to score all the balls reliably. Okay, so there's a bunch of assumptions in that way of thinking that are wrong about how you can reliably control things. So the first assumption is that you can tell the flywheel to go at a particular speed by giving it a motor value. So you might think that we'll tell the motors to go at 70% speed, and that corresponds to a fixed RPM, and that whenever we tell the motors to go at 70% speed, we're always at that RPM. Well, that assumption isn't correct. What RPM the flywheel actually goes at depends on a lot of things. It depends on what friction there is in this mechanism. It depends on the freshness of the battery or the motors. It depends on the actual objects that are getting sent through. So if it's true that the accuracy of our mechanism is very sensitive to the RPM of the flywheel, what you actually need to do is measure what you care about. You need to put a sensor that will let us measure what the RPM of the flywheel is. In our case, we ended up putting what's called a Hall effect sensor, which detects the presence of a magnetic field, and then we put a magnet on the shaft. So as the magnet spins around on the shaft past the Hall effect, we can count how many times per second it spins past, and that will give us an RPM. There are other sensors that let us do this also, and we could have come up with other solutions. But the point is, if you're assuming that you need the flywheel to go at a certain speed, you gotta put a sensor on it that will measure that speed. Okay, the second assumption that I heard people saying was, well, we'll hold the trigger down until the indexer has fed one ball through. Okay, well, so the assumption there is that either there's a fixed amount of time that corresponds to one ball going through, and that's obviously not true because it depends on how close together the balls are, and it's chaotic in the ball holder. There might be a couple balls close together, and then we might have to run the agitator to break them up, and so there might be a gap between the next ball. The other assumption is, well, okay, surely the driver can just see, right? The driver holds down the trigger, and they can see when the ball shoots out of the flywheel, and so then when they see that a ball is shot, they just let go of the trigger, and they've shot one ball. Well, the assumption there is that the indexer is going slowly enough so that by the time you see a ball exit, the next ball isn't already touching the flywheel. And that also might turn out not to be a valid assumption. Depending on how the indexer is built, maybe you need to spin the indexer in order for the indexer to push the ball into the flywheel. Maybe it has to be spinning so fast that when you let go of the trigger, there's some amount of momentum, and it's very difficult to prevent a second ball from going into the flywheel. So again, if you want to, if the kind of control that you want to provide requires that you be able to shoot exactly one ball at a time, and you don't want to accidentally shoot two balls or accidentally not shoot a ball when you're trying to. If you want to shoot one and only one ball at a time, you need to put a sensor that will let you know when a ball has been shot. one possible, we didn't do that this year, but one possible sensor that would have been very easy for us to put on is a photo gate that would sit right where the flywheel is. A photo gate uses reflected infrared light to detect whether or not an object is a certain range in front of it. And so it would tell us when we saw an object pass. If we had put a photo gate on there, then in software we could have controlled the flywheel very precisely according to where we saw objects passing. So again, the message that I want to deliver for next year, and hopefully you're watching this next year, so hey guys, it's a new year. If you are assuming that we're going to be able to control the mechanisms in some particular way, think hard about what are you assuming we're going to be able to control. And then make sure you talk to software about what is the sensor that they need to make sure that they can provide control over that mechanism. All right, good luck.